As wireless spectrum becomes more crowded, RF interference has become one of the biggest challenges facing today's tactical wireless networks. Today, we will be demonstrating Silvus's Manet interference avoidance technology, also known as Man-IA. To demonstrate this, we've put together a 5-radio network consisting of Streamcaster 4200 and 4400 radios. Over here in the window, we have 2 Streamcaster 4200 radios connected to Obscura miniature HD cameras. Those are streaming at full 1080 resolution back to our receiving laptop. We have a 3rd Streamcaster 4200 radio here, part of the Man-IA network. A 4th radio, a Streamcaster 4400, which is connected to our laptop and acting as the main receive point for the video streams in the network. Our laptop is displaying the 2 video streams coming from the Obscura cameras. It also has 2 spectrum analyzers connected to it. One of those spectrum analyzers is operating in S-band, and the second one is operating in C-band, so we can monitor the entire spectrum. We have a 5th radio here, another Streamcaster 4400. And finally, we have 2 Streamcaster 4200 radios that have been modified to output an interfering signal. We can control what frequency the interfering radios are transmitting on by utilizing the multi-position switch. We will be using these modified radios to interfere with the network and see how the network reacts in real time. Looking at our screen, we have the spectrum analyzers up top with the S-band spectrum analyzer on the left and the C-band spectrum analyzer on the right. On the far right, we have our 2 HD video feeds. Those are coming in live. And here we're showing the Man-IA section of the Streamscape GUI. The software currently supports monitoring up to 8 frequencies. However, for simplicity, we will be monitoring 4 frequencies for this demonstration: 2210 and 2290 MHz in S-band, and 4500 and 4700 MHz in C-band. The radios continually measure interference across the Man-IA channels and share this information with all radios in the network with minimal impact to network performance. Using this data, the radios automatically determine which of the channels is best for the network to operate on. We can see the real-time noise across all 4 channels in the table below. Right now, the network has determined that 4700 MHz has the cleanest channel, and that's denoted by the green highlighted column. Just above the table, we have a bar chart which displays a real-time graphical representation of the interference across the network from the perspective of each radio. If we look at the C-band spectrum analyzer, we can see the network currently operating on 4700 MHz. So now I am going to enable one of the interfering radios at 4700 MHz and see how the network reacts. If we keep an eye on the table below, we can see that the network has now moved to 4500 MHz. And if we look at our spectrum analyzer, we can see the interference coming in quite strong at 4700 MHz. If we look over at our video feeds, you'll notice that those are still flowing in nicely with little to no interruption. Now, leaving the first interfering radio on, I'm going to grab our second interfering radio and turn it on at 4500 MHz and force the network to make another decision. So now that it's turned on, we can see the network quickly adapted and moved to 2290 MHz. The videos are once again flowing in perfectly, and we can see our 2 C-band interfering radios both on and coming in very strong. And our network transmissions now happening at 2290 MHz. What I'm going to do now is take the second interfering radio and follow the network to 2290 MHz and see what happens. What we would expect is that the network would move back to 4500 MHz since that was previously the cleanest channel. What we're actually going to see happen, as I change the interfering frequency, the network will go to 2210. It's going to dwell there for a moment while the radios confirm that the interference has indeed left 4500 MHz. Once confirmed, the radios will move to the best channel, which is 4500 MHz, which is done now. And once again, the videos are flowing in great. Silvus has envisioned a new paradigm of spectrum access, where the network is capable of autonomously overcoming interference at an operational tempo, while providing radio operators with high-level spectrum awareness and control. Silvus's Man technology is the first of many capabilities focused on solving the challenges associated with operating networks in congested spectrum. Stay tuned for many more enhancements from Silvus to come.